Reading book. Understanding pressure. A fundamental concept in physics and engineering. What is pressure? Pressure is a physical quantity that measures the amount of force applied per unit area. It is a fundamental concept in physics and is used to describe a wide range of phenomena, from the behavior of gases and liquids to the mechanics of solids. The SI unit of pressure is the Pascal, Pa, which is defined as 1 Newton per square meter, N per square meter. Other common units of pressure include atmospheres, ATM, and pounds per square inch, SI. Pressure can be measured using a variety of instruments, such as barometers, manometers, and pressure gauges. In a gas or liquid, pressure is created by the collisions of the particles with the walls of the container. The greater the number of collisions, the higher the pressure. In a solid, pressure is created by the deformation of the material in response to an external force. What is pressure? Pressure plays an important role in many areas of science and engineering. It is used to describe the behavior of fluids in pipes and vessels, the operation of engines and turbines, and the strength and deformation of materials under stress. Understanding pressure is essential for designing and optimizing a wide range of systems and processes. At what point is air pressure harmful for humans? Exposure to high-pressure environments can be dangerous for humans as it can cause various health problems. One of the most well-known conditions associated with high-pressure environments is decompression sickness, also known as the bends. This occurs when a person moves too quickly from a high-pressure environment to a low-pressure environment, causing the formation of nitrogen bubbles in the bloodstream. This can lead to symptoms such as joint pain, fatigue, and shortness of breath, and in severe cases, it can even be fatal. In addition to decompression sickness, exposure to high-pressure environments can also cause lung damage, as the increased pressure can cause the lungs to expand beyond their normal capacity. This can lead to air leaks, lung collapse, and other respiratory problems. The specific level of pressure that is harmful to humans depends on various factors such as the duration of exposure, the rate of pressure change, and the individual's health status. At what point is air pressure harmful for humans? It is important to note that exposure to high-pressure environments is often associated with certain occupations, such as deep-sea diving or working in pressurized environments like submarines or hyperbaric chambers. If you are involved in such work, it is recommended to consult with a medical professional or occupational safety expert for more specific information regarding the safe levels of pressure for humans. Pressure is a key component in the operation of engines, such as those found in cars, planes, and boats. In these engines, fuel is burned to produce high-pressure gases that push pistons or blades, generating motion and power. Furthermore, pressure is essential in the field of construction and engineering. Engineers must take into account the pressure that various structures will be subjected to, such as the weight of a building or the force of wind and water. Understanding these pressures is critical in ensuring the safety and stability of structures. Pressure is also an important concept in the field of weather forecasting. Atmospheric pressure, which is the weight of the Earth's atmosphere pressing down on the surface, can be used to predict changes in weather patterns. High-pressure systems typically bring clear skies and dry weather, while low-pressure systems often result in cloudy, rainy, or stormy conditions. In summary, pressure is a fundamental concept that plays a significant role in many aspects of our lives, from energy production to construction to weather forecasting. Its importance is reflected in the wide range of applications and fields that rely on it. Dangerous pressure. Pressure is a physical phenomenon that can have dangerous consequences depending on the context. In mechanical or industrial settings, high pressure can cause explosions or equipment failures that can lead to serious injury or death. Similarly, in medical settings, high blood pressure can increase the risk of heart attacks and strokes. Additionally, changes in air pressure during air travel or scuba diving can cause decompression sickness, a condition that can be life-threatening. It is crucial to understand the risks associated with pressure in any given situation and take appropriate precautions to ensure safety. One context where pressure has significant effects is in the ocean. As we go deeper into the ocean, the pressure increases due to the weight of the water above. At the surface of the ocean, the pressure is around 14.7 psi, which is equivalent to the atmospheric pressure. However, for every 33 feet, 10 meters, of depth, the pressure increases by 14.5 psi. At a depth of 1,000 feet, 305 meters, the pressure is around 442.5 psi, and at the deepest part of the ocean, the Challenger Deep in the Mariana Trench, the pressure is estimated to be around 16,000 psi. Dangerous pressure. This immense pressure has significant effects on the biology and behavior of deep-sea creatures. For example, deep-sea creatures have adapted to survive in high-pressure environments by developing unique physiological and behavioral adaptations. These adaptations include changes in body size, shape, and composition, as well as changes in feeding and reproduction behaviors. Additionally, the high pressure in the ocean presents technical challenges for human exploration and submarine technology. To explore the deep ocean, scientists and engineers must design and build specialized equipment that can withstand the immense pressure and extreme conditions of the deep sea. In conclusion, pressure is a physical phenomenon that can have significant effects on the biology and behavior of deep-sea creatures and presents technical challenges for human exploration and submarine technology. It is crucial to understand the risks associated with pressure in any given situation and take appropriate precautions to ensure safety. Pressure for engineer. Pressure is defined as the force per unit area exerted on a surface. In engineering, it is a fundamental concept that is used to describe the behavior of fluids and gases, as well as the deformation of solids. Engineers use pressure measurements to design and optimize systems, such as pipelines, turbines, and engines. They also use pressure sensors to monitor and control various processes, such as manufacturing and chemical reactions. In fluid mechanics, pressure is a key parameter that describes the flow of fluids through pipes, channels, and other structures. Engineers use pressure measurements to calculate the flow rate of fluids, which is essential for designing efficient systems. For example, in the oil and gas industry, pressure measurements are used to monitor the flow of oil and gas through pipelines, and to detect leaks or other problems that could affect the safety and efficiency of the system. Pressure for engineer. In thermodynamics, pressure is a key parameter that describes the behavior of gases and their interactions with solids and liquids. Engineers use pressure measurements to design and optimize engines, such as internal combustion engines, which convert the energy of a fuel into mechanical work. Pressure measurements are also used to design and optimize gas turbines, which are used in power generation and other applications. In material science, pressure is used to describe the deformation of solids under stress. Engineers use pressure measurements to design and optimize structures, such as bridges and buildings, to ensure that they can withstand the forces that they will be subjected to during their lifetime. Overall, understanding the principles of pressure is crucial for engineers to ensure the safe and efficient operation of systems and structures. By measuring and controlling pressure, engineers can optimize the performance of systems, reduce the risk of accidents and failures, and ensure that structures are safe and reliable.